So, over the last little while, I've been introducing you to the world of computers. We've looked at how to make your own computer, how to upgrade your computer, and for those of you overtime peeps who are watching, we've even built a third computer in the meantime. The reason why I've been telling you so much about computers is because I think they're very interesting and powerful machines that aren't necessarily like this mysterious black box, but are actually quite simple to understand. Adult Legos is a phrase you'll often hear me say when it comes to this kind of stuff. That's because like a lot of this technology is built around this idea of like these various pieces that just kind of like slot and click into the place where they belong, like Legos. Which means that in order to make something like a computer, like you don't really need some random degree. The only thing that you really need to do is kind of like follow the instructions and place the piece on top of like the other piece in the slot that it belongs, and then it's done. It's actually quite simple. However, there's something which I've yet to tell you about, which if you don't know, can turn this very powerful computer into just a useless paperweight. To show this to you, here I have the computer that we built a while back on overtime. It has a Ryzen 5 7600 CPU, it has 32 gigs of DDR5 memory, and it has an RTX 3080 GPU. All in all, just very good, powerful components, which should make this computer run very well. But watch what happens when I actually turn this computer on for the very first time. I'm gonna power it on right now, and then we'll have the display right here, and let's see what happens. So, first of all, we get like this little like intro bit, like the logo of the motherboard. And then we get this screen right here, which just displays some of the stuff that we have in here, but not much else. And most importantly, it says there is no bootable device found. Like, what does that mean? Well, what that means is that we're missing the second big part of the world of computers, which is the software. You see, so far the only thing that we've been looking at is all the physical parts that make a computer, also known as the hardware. However, we've not spoken at all about all the programs that make the computer do the things that it does. That's why today I want to tell you more about the basic idea of what software programs are, and I want to talk with you about these special programs called operating systems. Now, in order to understand what software is and what kind of role it plays on a computer, let's first get a very basic idea of what a computer is. You've probably seen this like cardboard representation of a computer before, which I used to like show you like what kind of parts there are on a computer and what they all kind of do. However, this representation right here, I still think it's like way too complex. What we need is something like super simple. I'm thinking like this thing right here, this flashlight. Yeah, I think that this right here is the perfect representation of a computer. But then how the hell could a flashlight be a representation of a computer, you may ask? Well, I'm glad you asked. That's because both the flashlight and the computer are electrical devices, which means that if you provide them with power and then turn them on, they produce something. In the case of this flashlight, it is light. In the case of the computer that you're watching this video on, if you pause the video right now, welcome back, it is a display of this very image. But hold up, isn't that like way too simplistic? I mean, a flashlight right here, the way that it works, like it takes power and then it runs it through a wire which becomes so hot that it actually starts giving off light. And that's it. But in the case of a computer, like, you know, that does communications, calculations, and I can even tell it what to do. So how are these two even similar? Well, that all comes back to what I said at the very beginning, and that's that both these things are electrical devices, which means that they run the same electricity and thus the same rules as each other. Even though we may often say that a computer is like thinking or communicating or calculating, it's not really. It's just electricity running through wires, similar to a flashlight. However, the biggest difference comes in that this flashlight can be either on or off, whereas a computer can be in many different states. To show this to you, I have made a more complex flashlight which can be in two different states. As you can see right here, we have like an output which has two little lights, where if I give the input to number 1, we see that only one output light turns on. But then I give the input to number 2, we see that 2 lights light up. As you can see here, it's like a very simple electrical device. However, depending on what input I give it, it does different things. Now, a computer works via a very similar principle. However, this thing here has a lot more parts and thus a lot more states that it can be in. One thing that I think is like super cool is that the earliest computers worked very similar to like this thing right here, where as you can see in this picture, in order to make this computer work, you had to like plug the right wires into the right places to make it do what you wanted it to do. However, this wasn't really like the most practical computer. Because if you wanted to do just like one simple thing, you already had to like grab out the wires and plug and replug them into the right places. This means that we need to find some way that we can make the computer do not just one action, like go from one light to 2 lights, but what would actually be better is if we could like combine a couple of simple actions together such that we could make more complex and thus useful actions. In order for us to do this, let's go take a look at this like little light example again. So let's say that what I wanted to do is a more complex action where first of all I want to turn on like 1 light and then I want to turn on 2 lights. Now, in order to do this, like I can plug the wire first into number 1 and then I can plug the wire into number 2. Now, since this device will always be the same, what I can do is I can kind of like make a recipe for it, where in order to turn on lights 1 and then 2, my steps would be plug in wire 1 and then plug in wire 2. And because this will always be the same and this works, I can just like write it up this recipe and then you can perform this without really having to think about it. This recipe thing is like the basic idea of what is in fact a program. It's just a set of instructions for making connections within your computer in order to do certain things. Now in this situation right here, the program may not actually be of that much help, since, well, I mean, the instructions are pretty straightforward, and in order to execute them, you still need to like plug it in both all by yourself. So it doesn't really make that much of a difference. However, for like the older computers, they had so much more like complex programs that wires could have to look like this, which could be very, very complex to do. So what they would do is they would like create these program boards where all the connections would already be made, and then they could slot in that program board right into the machine, such that the only thing that you would have to do is just take this board, put it in, and it would run the program. These were like the actual computer programs, which instead of like telling you what to do, would actually make the connections for you in order to turn the parts on the computer that needed to be on for the task that you wanted it to do. However, let's be honest here, this doesn't really seem that much easier. Now, does it? Because like, let's take the example of like this recipe right here, like where we wanted to turn on light 1 and light 2. If we pre-make this on the board and then turn it on, basically it turns on everything at the same time. We don't have first light 1 and then light 2. Also, what we have is that if we want to like have a different program, we either have to have like a whole bunch of these boards, or every single time we have to pull out all of the wires and then rewire it, which, I mean, like how much time does that really save you? It would just be so nice if we could just like write out a program on a piece of paper, because if we look at this paper right here, it's something which once I've written this, I can just copy the paper and give it to you. Also, once I give it to you, it doesn't really take up all that much space. And because we can just read it from top to bottom, we know what comes first and what comes after, and not just everything all at the same time. So what can we do so that like we can write programs on a piece of paper? Well, one thing that we can do is like write a program on a piece of paper in a language that a computer can understand. This right here is a punch card, which works kind of similar to like the program boards that we just saw, but instead of using all these wires, it uses holes in the paper. And to explain like the basic idea of this, take a listen to this thing right here. Do you get it? Now don't worry if that was like too vague for you, I'll try and explain it properly this time. So in this system, instead of like having these wires to make the connection, what you actually have is like you have these brushes that can like connect to each other. However, what you can also do is like put this card right through it such that like once there's paper in between them, the two ends will not make a connection. The only place where they will make a connection is if there's a hole inside the card where these ends can touch each other. As such, if we were to use punch cards to like program our little like instruction set right here, what we would have is we would have these brushes like go over our little paper, and then first one would connect right here in the hole, and then it would disconnect, and then two would connect in the hole, and then disconnect. So what we see here is like we can run the program without even touching any wires at all. It's like the same idea with like this little music box thingy, where we see we have all the notes present that we may want to play, but then depending on where like the notch is on like this little cylinder, that's the note that actually gets played. And the only thing that we need to do is just turn this little thing right here. Now this is like a super big deal, because what we've done is like we've taken these actions, these individual actions of like taking a wire, plugging it in, taking it out, plugging it back in again, and we've not only like written it on a piece of paper, but we've actually put it on paper in such a way that it's actually being done. Which is like in the same way that this little cylinder right here, it doesn't just have like happy birthday written on it, it actually plays it when we turn this little handle. Now I can imagine that that's like a lot of information to take all at once. So let's just take a deep breath. And let's recap what we have so far. Computers are just electrical devices, which like if you give them some electricity, they do something, like a flashlight. Now, since computers have more options than a flashlight, like depending on which connections we allow them to make, they can do different things. And then if we can combine like these different individual actions into like a recipe, we can make a program for a more complex action. And then if we can write these programs into a way that the computer understands, then we can make the computer do these actual things without us needing to do anything. If you understand just like the rough idea of that, then that's fantastic. You're more than ready to be confused again. Because whilst you may not really have heard about like wire boards or punch cards before, I would not really be surprised if you're somewhat familiar with the terms software and hardware. And if you've heard about hardware and software, you've probably also heard that like hardware are like the hard physical components of a computer which you can touch, whereas software are all like the programs of a computer which you cannot touch. So then, how the hell am I holding a program in my hand right now? Well, that's because we've now mostly turned like these physical programs into a digital format. But how do we do that? Well, you've probably heard me talk before about like hard disk drives or solid state drives, which are the devices in your computer that store data. You may have also heard that they work by storing ones and zeros. But then, how do they do that? In the case of the hard disk drive, here there is a magnetic disk with like a read-write arm that goes over it. This is like very similar to a final record, which is all these grooves and then a needle that reads these grooves. However, instead of it having grooves, here each location on this disk is like a different magnetic polarity, which is either one or the other side of a magnet. Now, these polarities can be like read and changed by the arm. As such, what we can do is we can say like this side of the magnet is like a 1 and this side of the magnet is a 0. In the case here of like the SSD, there is like this memory chip which is installed. And this little memory chip has like all these small little cells that can either allow electricity to pass through or not pass through, which will create a 1 or a 0. But then wait a second, if we have like this SSD, like this rectangle shaped thing, which can like have small blocks allowing electricity to pass or not to pass, isn't that like similar to this thing here? Exactly. You see, ones and zeros are like the machine language that allow us to like make a connection or not make a connection. And the reason why people have been looking for all these sorts of weird ways, like using magnetic disks, using like these flash cells, is because this is the exact same way of like speaking the machine language of connecting or not connecting a wire, of like having a hole or not having a hole. Which means that like right now you don't really have to fiddle around with wires or like these punch cards anymore, because we now have these devices that store these connections, these ones and zeros, like in them, and they can just be read by just passing electricity through them. Because of that, we no longer need to touch our software or our programs at all, because we just have them right here. Which is great to know, because right now what we see here is that this computer can do like a whole bunch of things. However, in order to do it, it needs to make the right connections, which we do by like storing all these programs into like a drive right here and then plugging the drive in. However, that also means that if we buy this like brand new drive, it has like nothing on it, so it cannot run any programs because there are no programs on here, which means that the computer won't do anything because there are no connections that it can make, thus like we've solved the mystery, right? Well, not entirely, because yeah, it is true, there was like absolutely nothing on this drive. But even if we were to put programs like Word or Internet Explorer or Steam on this drive, it wouldn't really behave any differently. That's because if we only put these programs on the drive, like the only thing that we do is like we take these recipes and just put them on the drive. But what we haven't done yet is like put ourselves in the drive. But then what the hell do I mean with putting ourselves inside the drive? Well, if I take this program for instance and put it into the machine, I decide at this point in time that I want to run this program. However, if I store like a bunch of programs onto this one drive, which one gets to run first? Deciding which program gets to run at what time is one of the main tasks of operating systems. Now I can imagine that the word operating systems may be quite a big, intimidating word, but if I just shorten it down to like OS and then make it MacOS or iOS, Does that sound a little bit more familiar? Basically, what operating systems are like the first program that runs when you start up your machine. As such, like, you interact with this program so much that it may likely not even feel like a program to you at all. Like, do Microsoft Windows or Apple macOS sound and look familiar? At the same time, for like the very small computers that you use on a probably daily basis, do Android or iOS look and sound familiar? Like, all of these things are operating systems. Now, the tasks of operating systems are actually quite complex, so I'll probably talk about them more in depth in like a future video. But for now, like, it's good to imagine these programs as like programs that just allow you to select like which program you want to run, and then they find that program, load it up for you, and run it. What they also do is like they make sure that each program kind of like runs properly, and if it doesn't, they'll stop it before it can damage any more of your system. Basically what they've done is like taken over your role as the computer operator, where you no longer have to look for the exact location where a computer program is stored, then have to get that program and load it in. You just have to click on the icon and the computer does the rest. So that's the thing that's missing from this overtime computer. It has all the hardware that it needs, however it has no operating system. So it doesn't know what to start. There's no bootable device found because there's nothing on here that has like this very first program which it can run. So it just kind of sits here displaying some of the stats that it has and telling you that it doesn't know what to do now. So now that we've diagnosed that problem, why don't we go and fix it? In order to install an operating system, what we need is another computer and a USB drive. Now, if you've come from the world of Windows or Mac, like, it may seem to you that there's only one operating system that exists. However, there's actually like a lot of operating systems that you can choose from. It's kind of similar how like a while back we all thought that like Internet Explorer was like the one and only way to access the internet, but then we discovered things like Chrome or Firefox which also allow you to do the same thing. Now, macOS is something that tends to only come pre-installed on Apple computers, but Windows is something that you can buy and put on pretty much any other system. But what if I told you that there was another option? This right here is Linux Mint, and it's a Linux operating system, which means that it's like a first computer program just like Windows. However, this right here is like a different program, in the same way that like Firefox and Internet Explorer do the same thing, but they're also different. The biggest difference between like Linux and Windows is that Windows is made by Microsoft, which is a private company. As such, what they do is like they sell their program for a pretty decent price. They also like don't really share entirely how their program runs, which means that there can be like advertisements, trackers, and required sign-ins in there which you may not even know about, and even if you do know about them, you can't really get rid of them. Linux, on the other hand, is like a free open source program, which means that it's like made by a whole bunch of people together who all share and review all the aspects of the program online. As such, these people are able to check whether there's unwanted stuff in this program and get rid of it. Also, people can like make their own version of this program since, you know, it's all free. Linux Mint right here is like one single version of Linux, but there's like a whole bunch of different versions out there, like for instance Android right here. Yes, like the operating system that's on like a whole bunch of phones is also based on Linux. So if we want to install like this Linux Mint operating system, we need to go to the website and then right here click on download. What we see right here is that we already get like a couple of options for which operating system we want to download. Like, do you want to have the most modern operating system, but which may be a little bit more intense? Do we want to have like a more stable, robust thing, which is like a little bit easier to run on like maybe an older machine? Or do you want the most like lightest, easiest to run operating system that doesn't really take up that many resources? Like right now we already have a couple of options which we don't get in Windows. Anyway, we have a pretty good PC, so let's go with this first version right here. And then what we do here in order to download is we scroll down and we go to like the mirrors, which are like all sorts of servers online which hold this operating system, and we can choose from which one we want to get it. So you can just go with the first one, or you can go with one that's like closer related to you. Now, since we can get this file from like a whole bunch of different computers from around the world, it may be possible that one person on these computers has messed around a bit with our file. So what we need to do is once we've downloaded it, we need to verify it whether the file is okay. So in order to do this, we go to Integrity and Authenticity, which has two files right here, which allow us to like take the fingerprint of the program and then see whether that fingerprint corresponds with like the fingerprint that the developers have taken. So we save these two files into the same folder as the file that we just downloaded. However, then we still need to have like a fingerprinting software to take the fingerprint of this program. That's what we do right here by clicking on Verify, and then we scroll down and we click on Verify on Windows, where we find that we need to download this program right here. This right here is our fingerprinting software. And if we scroll down to about here, we see Windows, we can download this thing right here. And then once that's downloaded, we can go and install it, which is what we do right here. So we click next, next, install. Now what I'm doing right here is I'm going through this rather fast because I know exactly where I need to click since I've already done this a couple of times before. However, if you're doing this for the first time, what you probably have seen is that these pages contain like a lot of very useful information and detail, which I would definitely recommend to read up on and really see what you're doing, why you're doing it, and how you're doing it when you're doing it for the first time. So now that we have the fingerprinting software installed, what we want to do is we want to open the PowerShell or command prompt, which is something that you can do by going to your Windows logo right here, right clicking, and then you'll see that right here there's something called Windows PowerShell. If you click on this, it will open a PowerShell, which is basically like a way for us to send messages to the computer to tell it to do certain things. So where we are right now is we're just in the Michel folder. So I want to go to my desktop, and then I want to go to like the folder that we're in right here, which is OS, which as you can see right here, I'm right here in my desktop, and that's OS. So what we're going to do is we're going to type cd for change directory and then desktop/OS. Then we're going to hit enter, and then you see that right now we're desktop/OS. So we're right now in this folder right here. So what we need to do now is we need to start the fingerprinting software. So we go to this page right here where it says we need to copy this code right here. Then we can paste it into here. Now what you see here is that it has filename.iso. That means that we need to take the file name from this ISO file, and we need to remove file name here and paste it into there. And now if we click enter, you'll see that we get like a string of numbers and letters. Now this string of numbers and letters is the fingerprint of the program. So if we go right now to this txt file and we open this, what we should see here is that we have the very first option right here, is that this code right here matches this code right here. Now what we see here is we see 90A2A, and what we see here is 90A2A. This seems to match, so that means that the program is okay. So now that we know that the program is okay, all we need to do is just put it on a USB stick. So let's get a USB stick and plug it into our computer. However, this is not going to be as simple as just copy pasting the file onto the USB stick, because what we have right now, it's just like another program on our computer. So that also means that if we put it on the USB stick, it will just be another program on the computer, and our other computer won't know where to run it first. So what we need to do is we need to make it a program that runs when we start up the computer, which is making it bootable. For that, what we need is this program called Rufus, which is a program that turns USB sticks into like bootable devices. So what we do right here is like we download the latest version, which looks something like this. Now up top here, you can select your USB device, which right here, mine is already called Linux Mint. And then we can select our boot selection, or like the file that we just downloaded. So we're going to click open. And now what we see here is basically everything is generally quite okay. I would just leave this all the same. However, one thing that you really have to watch out for is that this USB device doesn't have anything on it that you want to keep, because what we're going to be doing is basically erasing all the data that's on there. If you're okay with that, what we can do here is hit start. It will say again like, hey, do you want to make sure that you run in ISO mode? Then what we'll see is like it will give us a warning that all data on the device will be destroyed, which is okay. So we're going to click OK. And then it's going to get started. And now when that's done, we now have an operating system on this USB stick, which is bootable. So let's go plug it into our computer. Okay, so we're starting out with like the logo of the motherboard, which is, I mean, the same as before. But now we see this little menu which says Start Linux Mint, which is what we want to do. So let's press enter. And then we get to this right here, which should be a very familiar looking desktop. As you can see, we now already have an operating system, because what you see right here is like we can move around with our mouse, we can like open up like a web browser, we can open up various different programs right here, like we have an entire office things, like for instance we have Word right here that we can open. And we have like files and stuff that we can explore. One thing that's important to realize is that this right here is not the entire operating system just yet. This is in fact an operating system, but it's an operating system that's only on the USB that we have just installed. See, Linux generally allows you to like try out their operating system before you actually install it. So what you see here is basically like a tryout where you can just like go around and see like, hey, do I like this program? Do I think this is going to be fun for me to install? And if you feel like installing, you can just go and click on here, install Linux Mint, and it will install it to your system. Now, generally these steps are very similar to just like installing Windows, which means you just follow the instructions as it guides you for installing the operating system on your computer. Now, once it's done, you'll have the operating system on your computer, which I mean, doesn't really look that much different because the tryout was like pretty much the same thing as the actual thing. But yeah, you'll now have an operating system on your computer that you can do all sorts of different things with. So that is the world of computer software, which is basically just stored instructions to make your computer do different things. Now we call these instructions programs, which are nowadays all stored on your storage drive, which means that what we need is an operating system, which is the very first program that we start when we start up the computer, which allows us to choose which program we want to run when the computer is turned on. I hope that this like somewhat makes sense and that this video has allowed you to get like a better idea as to like how the software side of computer works. Now, I've definitely not gone in depth into like all the tasks of an operating system, nor have I explored into like what all different programs can do, or even like how to make a program yourself. And I can also imagine that like the last part of like the Linux operating system may have been like a little bit too fast for you, because like I did all sorts of different things with new programs. But hey, that's okay, because what I wanted to share with you today is just like a general idea of what computer programs are and what kind of function they play within a computer. And also what I wanted to tell you is that it's like this first program called an operating system, and that, you know, like this program is something that you can change from the one that you're familiar with if you want to. So if that's what you got out of this video today, then that's great. I hope you enjoyed it, and if you have any further questions, just let me know in the comments down below. I know this was like a big information video about software, which may not have been the most fun video to watch. However, I want to make sure that we have like a good solid foundation before we move on with the rest of the stuff on this channel. And if you enjoy what I do with this channel and you want to support it, check down the description down below for overtime, where for $1 a month, like I make extra videos for you, where today what we're going to be doing is we're going to be making this thing right here. This is the very first time I've done anything with like electronic stuff, and actually it's not what we're going to be doing. I've already done this right before, and we're just going to be going through the process of making like this little board and like these little lights. I had no idea what I was doing. It was absolutely just like trying to figure it out, but I think it's fun to just like experience it together, and hey, you know, at the end of the day we were successful, so I guess the end is spoiled. But yeah, you know, if you want to see extra videos for $1 a month or for free with Twitch Prime, you can go and support the channel. Check out the description down below for overtime, and thank you all so much for watching this video. I hope you enjoyed it, and I'll see you all next time.